In this video, we'll be looking at how we can use the formulas that we know for volume and surface area and work backwards to solve for dimensions. So let's look at this first example. Let's say we have a box of crackers that we know has a volume of 5,000 centimeters cubed. The volume is 5,000 centimeters cubed. We know the length of this box is 25 centimeters, and we know the width of this box is 8 centimeters. Can we use this information to solve for the height? When we know that the volume of a box, or the volume of a cube, or the volume of a rectangular prism is length times width times height. So if I plug in everything I know, a volume of 5,000, a length of 25, a width of 8, and an unknown height, I can use algebra to work backwards and solve. So simplifying this, 25 times 8 is 200. And then moving the 200 to the other side, I'm going to divide 5,000 by 200. And that will be my height. And 5,000 divided by 200 is 25. So the height of this box that has a volume of 5,000 centimeters cubed is 25 centimeters. So I plugged in everything I knew, and then I worked backwards to solve for the height. So here's another problem. Let's say we know that on a cone, the lateral surface area is 120 centimeters squared. And this cone has a slant height of 13 centimeters. Can we find the radius? Can we find this distance from the center of the cone to the outside? The lateral surface area refers to the part of the cone that, if you're eating like an ice cream cone, you'd be grabbing. That's the lateral surface area. So that has a surface area of 120 centimeters squared. If you look at your formula sheet, you see that the surface area of the lateral surface is equal to pi times the radius times the slant height. So again, substituting the things we know, the surface area is 120 and the slant height is 13, we can use algebra to rearrange this. Take 120, divide it by pi times 13, and that will give us the radius. Make sure when you're doing this on your calculator you're using the pi button. You're not rounding or approximating pi. Use the pi button, be exact. So 120 divided by pi times 13 would give us a radius of about 2.9. So the radius of this cone is 2.9 centimeters. And finally, let's say we have a sphere that we know has a volume of 500 centimeters cubed. And we want to work backwards and find the radius. So we know that the volume of a sphere is equal to 4/3 times pi times the radius cubed. So plugging in 500 for the volume, I need to solve for the radius. And this is a little bit more complicated. I'm going to start by cross-multiplying and bringing the 3 that's in the denominator of the fraction up. So 500 times 3 gives me 1,500, and that's equal to 4 times pi times the radius cubed. Then I'm going to rearrange this equation, and I'm going to divide 1,500 by 4 pi. And that will be equal to, again, my radius cubed. So rearranging and dividing, I end up with 477.46 equals the radius cubed. and I'm not quite done. I need to do something about that cube attached to the radius. And what I can do is take the third root of 477.46. So this is different than the square root. It's a special button on your calculator. Try and find it. The third root button. So if I take the third root of 477.46, I get about 7.8. So my radius of this sphere is 7.8 centimeters.